Hi, in this video, we're actually going to be working on computing the inverses of a matrix and not merely verifying whether or not they're invertible. So, as in similar problems, we're going to try to utilize technology to the best of our ability to save ourselves time or hassle or headache. And this is going to be no different. So, I'm going to show you a couple of different ways using technology that you can find the inverse of a matrix. So here we have Q, a 4 by 4 matrix. And let's take a look over at, let's start with the Sage cell here. Now, if we follow the activities of the text, then you'll be somewhat familiar with the setup. Here we have the matrix Q that we had laid out on the previous, on the whiteboard here. And then over here we have Q on the left hand side and the identity matrix on the right. And so what we know now is that if I take the reduced row echelon form of this matrix, what I'm doing is I'm applying a series of transformations to Q to get the identity and applying those exact same transformations to the identity. And when I'm done with that, that will produce the inverse matrix. So right now I have it showing M, but let's see what happens if I ask it to also show M.REF. So that will give us the reduced echelon form. And right, the left hand side has transformed from Q into the identity, and the right hand side has transformed the identity into this matrix, which we will call Q inverse. So according to this, Q inverse is 2, 7, minus 5, minus 1, 0, 5, minus 5, 2, 0, 0, minus 2, 1, 0, minus 3, minus 5, 5, 1. Alright, and so that will give you the inverse of Q. Now, I mentioned that this is, well, before I go into other ways of seeing if this is the inverse of Q, it's worth taking a moment just to check that this is in fact the inverse of Q. I.e., if I take this matrix and multiply it by Q, do I get P? So let's go ahead and define P. I'm just going to go ahead and copy that. And I'm going to put in the alleged values of Q inverse. So 7 minus 5 minus 2 minus 5 minus 5 2 1 5 minus 1 0 0 1. Let's go ahead and show P. Alright, so there we go. That's the P that we claimed. That's the same thing, right? And so let's go ahead and show P times Q in that last slot. And when I do that, I show, okay, when I take P and I take its product with Q, I get the identity. And just for fun, if I reverse that order, it doesn't make any difference. So that would certainly give you the inverse of Q. On the other hand, if I just started with Q, because I'm utilizing technology anyway, I could just go ahead and say Q inverses or inverse, right? Just like I can take the REF of Q, I can find the inverse for Q. And I get this matrix here, and let's just compare that to the P we found before, and certainly Q's inverse and P are identical, as we have seen already. So all of that's through Sage. If I want to use Desmos instead, I have Q all the way typed in here. I will know that if I type in Q inverse, I get this matrix, which we should be able to verify is the same as this matrix here. 2, 0, 0, minus 3, so on. I should be able to see that Q times Q inverse is the identity, and I could probably switch that order, and sure enough I get the identity as well. So we verified that this matrix here, which I've written here not as nicely, is in fact the inverse of Q. Alright, thank you very much.